Okay, so for example one, you were thinking of buying a new computer. The hard drive, well, this is an old question. We have solid state drives now. But the hard drive of a computer is a metal disk that spins while data is written or read from it. One of the specifications for the hard drive is that it spins at 7,200 RPM. So frequency is equal to 7,200 RPM. Nice. Okay. So frequency is 7,200 RPM. Now, do you guys remember the units for frequency? Hertz. Excellent. Okay. So now for 7,200 RPMs,
Did you go to the doctor?
yeah, we're going to divide that by 60. Okay. So first we need to go, so question A is, what does this even mean? So what does 7,200 RPM means? Well, this just means that the hard drive spins at 7,200 revolutions per minute. Okay, and that's what that means. Easy peasy. Okay. B, we are going to determine the frequency in hertz. Frequency in hertz. So if we have 7,200 RPM and we want to get it to hertz, we're just going to divide that by 60. And if we punch that into our calculator, we will get 120.0 hertz. Okay, so that's it. We're just going to divide that by 60. Now, what does this measurement mean? Well, this means that the hard drive rotates at 120 times per second. Okay, so we can write that as 120.0 revolutions per second.
Was it still revolutions per second?
Yes, revolutions per second. Yeah, but we kind of hyphenate it. We just say per second, okay? Or 120.0 seconds minus 1. That just means 120.0 per second. So revolutions per second. We just kind of abbreviate that by removing the revolutions, okay? Because it just kind of goes without saying revolutions per second. Or 120 hertz. This is probably the easiest one right there. Okay. So that is question B. Now for question C, determine the period. So our formula here is T is equal to 1 divided by the frequency. So this can be 1 divided by 120.0 hertz. And that will give us an answer of 8.333 times 10 to the negative 3 seconds. So how do the units work out there? Another way that we can write this is 1. So the units for period is going to be seconds. Okay. So how the units work out for that? So 1 divided by 120.0. Now remember, another way of saying hertz is per second, like revolutions per second. So if we do second minus 1, that just means it's being divided by 1. So 1 divided by 120 revolutions per second, that will give us our answer of negative 3 seconds. Okay, so if you divide by something that has seconds in the denominator of the denominator, then it becomes the numerator of the quotient. Okay, that may make a little bit more sense when you see the actual calculation, okay? So yeah, so if you do that in your calculator, you should get 8.333 times 10 to the negative 3 seconds. Okay, that's how long it takes for the hard drive to make one rotation. Okay?
You went 1 divided by 120
Yes.
and got 0.0083 times 10 to the negative second.
8.333 times 10 to the negative 3. So, yeah. Same thing.
0.0083.
0.0083. Yep, so that should be 10 to the negative 3. If you move it, yep. Okay, so if you move that to 3 points over to the right, it will be 10 to the negative 3.
Do you have to move it?
No, you could leave it as 0.008333 seconds, because that will also give us an answer that has 4 significant digits, right? Cool, good questions. All right, so that was example 1. We will move on. So questions 1 to 3 on that practice problem handout of 5.2 are related to period and frequency, just kind of getting familiar with that idea. Okay, so make sure you guys attempt those on your own, please. The solutions are like on the questions itself. So I told you what the right answer is, but there are no like calculation solutions. I'll post those in a couple days, okay? Okay, example 2. Example 2. Okay, I'll make sure that I'm up in my window. Perfect. So example 2, we're finding period and radius of a student swinging a pail. Okay, so we're looking for the period. So question A, we're looking for the period. So we know the velocity is equal to 2.72 meters per second. And we know, so if we're calculating the period, so T is equal to the number of, the amount of time. So T is equal to time over the amount of cycles. So period is equal to time divided by the amount of cycles. So we know T is equal to 7.5 seconds and cycles is equal to 5, right? Because the person rotated that bucket around 5 times in the period of 7.5 seconds. So we need to find the period of that rotation. So we're just going to divide 7.5 seconds by the amount of cycles. So 7.5 divided by 5 cycles. And that will give us a period of 1.5 seconds. So it takes that student 1.5 seconds to rotate that bucket 1 time. Is that good?
Yep.
Okay, great. So now that we know the period and the velocity, we are going to calculate the radius. So we already know our velocity is 2.72 meters per second, and our T is equal to 1.5 seconds. So let's look on our formula sheet for something like that. We have velocity is equal to 2 pi r divided by t. So let's use that formula. So where do I want to go? Centripetal velocity is equal to 2 pi r over t. We're looking for r. So let's get r by itself. So multiply both sides by t. And then we will divide by 2 pi. So I'll get r is equal to period times the centripetal velocity over 2 pi. So now we'll just substitute in our values. We have r is equal to 1.5 seconds multiplied by our velocity, 2.72 meters per second, divided by 2 pi. And then we will get a radius of 0.65 meters. Final answer. Questions?
What's your T?
T is period. So T is period. So we needed to find our period first. So remember time, or T, period, so big T, is equal to the little t, time, over the amount of cycles.
Oh, okay.
Yeah, good question. So big T is equal to little t over the amount of cycles. Good question. Any other questions? All good? Excellent. All right, so moving on to example 3. Make sure I'm all set up here. Excellent. Okay, so example 3, we are determining the centripetal acceleration, so AC is equal to question mark, of a person driving at 60 kilometers per hour in a traffic circle that has a diameter, so D, of 120 meters. So first thing we need to do, we need to convert that speed of 60 kilometers per hour to meters per second. So if we divide by 3.6, that will give us our answer in meters per second. So 16.66 meters per second. We need to find the radius of the circle, not the diameter. So remember, the radius is half of the diameter. So radius is equal to 60 meters. And now we just need to find what our centripetal acceleration is. So we have V, we have an R, and we're looking for AC. So I see centripetal acceleration is equal to V squared over R. That looks like a perfect formula for this question. So AC is equal to V squared over R. And we have V and R, so we're just going to solve that, or substitute that in and solve. So 16.66 meters per second squared divided by 60 meter radius. Punch that into your calculator and you will get an answer of 4.6 meters per second squared is your centripetal acceleration. All good? Cool. All right. Next question. example 4. Nice. There we go. That works. Okay, we are looking for the centripetal acceleration again of a horse running around a circular track with a radius of 10 meters. And it does this every 14 seconds. So what is that going to be?
Period.
Yes, perfect. T is equal to 14 seconds because remember, the period is the amount of time required for an object to rotate one time, right? So if that horse is able to go around that circular track every 14 seconds, that is indeed the period. Very good. Okay, so we're looking for a centripetal acceleration. We have a radius and we have our period. So let's look on our formula sheet for something that all of those formulas or variables are on there. So right here, centripetal acceleration is equal to 4 pi squared multiplied by r over t squared. So let's use that one. So centripetal acceleration is equal to 4 pi squared r over t squared.
R squared over what?
Over t squared. Okay, so then we're just going to substitute that in right now. So centripetal acceleration is equal to 4 pi squared multiplied by r, which is 10 meters, divided by our period squared, 14 seconds squared. And crunch that into your calculator. You will get a value of 2.0 meters per second squared. All good? All right, 2 questions to go. So this is example 5, and it has a little intro video to kind of get you guys amped up for this question. Okay, so I would encourage you guys to watch that first. I will again provide that link onto the Google Classroom. Okay, so example 5. So example 5, calculating centripetal force. So we have a 100 kilogram person in a centrifuge, which has a radius of 8.80 meters. We are calculating the centripetal force if the person is spun around at a velocity or speed of 10 meters per second. Okay, so like we've been doing, let's go ahead and write down all the variables that we know. So we know the mass is equal to 100 kilograms. We know the radius is 8.80 meters. We're looking for the centripetal force, so FC is a question mark, and we know the velocity is equal to 10 meters per second. Okay, so we are looking for the centripetal force. So centripetal force, so FC is equal to the mass times the centripetal acceleration. Okay, so we are just rearranging the acceleration is equal to F net over M formula on the sheet. We're just rearranging that so it says force, centripetal force is equal to the mass times the centripetal acceleration. Okay, and we know from our formula sheet that centripetal acceleration is equal to v squared over r. So this is kind of one of those questions where you could substitute the two, you could combine the two formulas, or you could just solve for one or the other first. You could find the centripetal acceleration first and then multiply that by the mass to find the centripetal force. Or you can combine the formulas right away and just solve one. Okay, I'm going to combine the formulas. Just it makes it a little bit easier, and then I only have to do one calculation instead of two. Okay, so if we know that the centripetal acceleration is equal to v squared over r, and the formula for centripetal force is equal to mass times the centripetal acceleration, we're just going to substitute the v squared over r into the centripetal force formula. So you'll get centripetal force is equal to the mass multiplied by v squared over r. Okay? And then we can distribute that m into that. So we will get centripetal force is equal to the mv squared over r. Okay, that is not on your formula sheet. So you will need to know how to either create that formula from these two formulas, or you could just solve one formula at a time. But it's a pretty easy substitution, right? So when we are at this point, we can just substitute in all of our variables. So Fc, centripetal force, is equal to the mass, so 100 kilograms times the velocity, 10 meters per second squared, over r, which is 8.80 meters. Okay, so if you put this into your calculator, you should get a centripetal force of 1,136.3636 newtons, repeating. So if we round this to sig digs, we get 1.14 times 10 to the 3 newtons. So that is our centripetal force to answer the first part of the question. Good? Sweet. Okay, now the second part of the question, we're comparing this force of gravity normally, so we're calculating the force that person experienced in the centrifuge to what he normally experiences on Earth. So the way that we're going to do that, we're going just to find the ratio of the centripetal force to the force of gravity. So we're just going to do Fc divided by Fg.
9.81.
That is, so remember Fg is equal to what? Mass times the acceleration due to gravity, so mg. So 100 kilograms times 9.81. And that will give us a force of gravity of 981 newtons for that person on Earth. For a 100 kilogram person on Earth, they experience 981 newtons of force. So now we're just going to divide those two. So 1036.636. Now, we don't want to use our rounded significant digit answer when we're finding this value. We want to use the unrounded one, okay? So we'll use the 1136.3636 newtons divided by 981 newtons. And that will give us an answer of 1.16 Gs, or 1.16 times the normal force of gravity. Okay, easy peasy. Now we're going to do that again for if the person was rotating at 15 meters per second. So we're going to use the exact same formula. We're just going to put in 15 meters per second instead of 10. So centripetal force is equal to 100 kilograms times 15 meters per second squared over 8.80 meters. And we will get a centripetal force of 2,556.81 newtons, which is equal to 2.56 times 10 to the 3 newtons of centripetal force. And again, we're going to compare that to the normal force of gravity. And that will give us an answer of 2.61 Gs, or 2.61 times the normal force of gravity. So I just wanted you guys to notice the large increase in centripetal force, even though the velocity only changed by increasing of 5 meters per second. Okay, it over doubles the centripetal force experienced by that person. Okay, so even though it's just a small change of velocity, it will reflect a large change in the centripetal force of an object. Okay, one question to go, and that will be it for today. So example 6, we are calculating centripetal force acting on the same person in the same centrifuge, but this time we're given the period or the frequency in revolutions per minute. Okay, so just like we've been doing, we will write down what variables we know. So mass is equal to 100 kilograms. We know the radius is equal to 8.80 meters. And the frequency here is 15 RPM. How are we going to get that into hertz? Divided by 60, perfect. So that will give us a value of 0.25 hertz. Now, this is in frequency. When we are solving these problems, we want to be dealing with period. And period, big T, is equal to 1 divided by the frequency. So 1 divided by 0.25 hertz is equal to 4 seconds, which is our period. So that's the first thing that we need to do, is find the period. Second thing we need to do, so now that we know the T, we know the mass, and we know the radius. So we'll get out our formula sheet here. We know the radius and the period. So now we can find the centripetal acceleration. So step 2 is find centripetal acceleration. So AC is equal to 4 pi squared R over T squared. And we have R and we have T, so we can solve for centripetal acceleration now. So 4 pi squared times the radius over the period, 4 seconds squared.
Isn't it 4 pi r squared?
No, no, it is 4 pi squared times r over t squared.
But last question we did it 4 pi r squared.
Last, like on example 5, Micah,
Yeah.
it was the velocity that was squared on last question.
You're thinking of question 4, Micah? It was 4 pi squared r divided by 2t? Or t2?
Yeah.
Yeah, so no, it's not r squared, it's 4 pi squared times r over t squared.
Oh.
Yeah. Don't feel bad, Micah. When I was doing these calculations a few days ago, I definitely mixed up the squared on the r and the pi a couple times, so don't feel bad. Just a good teaching moment. We just have to be conscientious about the exponents there, or just careful anyways, right?
Okay.
Good question though. Okay. So yeah, so finding centripetal acceleration, we're at this point. We're just going to substitute that and plug that into our calculator. We will get a value of 21.71313 meters per second squared. So now that we have centripetal acceleration, we can find centripetal force. So this problem, I solved it kind of like in a stepwise, just to show you, stepwise manner, just to show you guys the difference of solving it kind of in one calculation and solving it in two. So you guys can kind of make up your mind after that. So centripetal force, Fc, is equal to the mass times the centripetal acceleration, which we have just found. Mass is 100 kilograms. Multiplied by our centripetal acceleration. And we will get a final answer of 2.2 times 10 to the 2 newtons. All right. And that is it for the day. So, questions about that? Concerns? All good?